Hello, my name is Dorian at the Metal Keck Lab, and today I am presenting a pipetting introduction for customers and graduate students who are making use of our facilities. The various pipette types around the Keck Metal Lab include the typical automatic pipette, multi-channel pipette, and Pasture pipettes in both glass and plastic types. They have been highlighted as seen here. Early pipetting was pretty unsafe to say the least. It required a glass tube that people manually sucked out of and hopefully didn't get into their lungs and mouth. Thankfully, we don't do this anymore. Starting off with Pasture pipettes, the most common is the graduated eyedropper. This is probably the type you're most familiar with, as it's a plastic tube with markings labeling volume. Another common type of Pasture pipette is the glass Pasture pipette, which requires its own bulb and tube. These are ungraduated and require the user to mark their own volume before use. The most common pipette we'll use around the lab are automatic pipettes. They compose of the plunger, tip ejector button, tip ejector, and pipette tip as highlighted. Despite branding and markings, these types of pipettes all utilize the same principle and similarly have their volume and volume selectors clearly labeled. Before using automatic pipettes, we must first learn the first and second stops. What are these stops? The first stop is used for extracting liquid into the pipette. It requires the least amount of resistance while pressing, while the second stop is only used for dispensing liquid inside the pipette tip. It's important to never pull liquid into the tip with the second stop and to only use the first stop for extracting. Here we have a visualization of the first and second stops, as well as the reset distance. This may vary among manufacturers and types of automatic pipettes as they consist of a first and second stop. It's important to play around with it and figure out where the stops are located and how much force is needed to meet them. So why is this important? As mentioned before, automatic pipettes come in various different sizes, branding, and manufacture. Despite this, they all work on the same principle and require the user to relearn and refamiliarize themselves with the automatic pipette of their choosing. Just because one form works with one does not mean that it may work with others even if they are the same brand and type. Steps for automatic pipetting. Select the desired volume using the dial on your pipette. Press down on the plunger 10 times and familiarize yourself with the first and second stops on your model of pipette, along with the tip ejector. Find the respective pipette tip size and secure it onto the pipette. Double check that it is the correct size and tightly secured to the tip. When ready to extract, press down on the plunger to the first stop outside of the solution. While holding the plunger at the first stop, submerge the tip into your solution. Slowly allow the plunger to lift up while keeping the pipette upright until the plunger is depressed entirely. Warning! Do not allow the plunger to snap back into position. This can cause liquid to splash into the pipette, causing corrosion, damage, and contamination. Once depressed, count to 3 seconds before removing the pipette from the solution and place it into the desired container or sample. To dispense this volume, slowly press down onto the plunger to the first stop, then proceed to press the plunger down to the second stop, even if liquid does not remain in the tip. This is just a good force of habit to make sure all liquid is removed from the tip of the pipette. The second stop should only be used to dispense the remaining volume and not in extracting. When finished, dispose of tip accordingly into the sharp spin using your pipette's respective ejector. Put away pipette back where you found it, and there you have pipetted using an automatic pipetter. Important factors to consider while pipetting is the viscosity of the solution. You may ask yourself, am I getting the right quantity or is this not extracting correctly? The precipitants. Should I filter my solution? Will precipitants mess with my experiment or are they needed in my experiment? And also the physical strain that pipetting can have on a person's hands. Pipetting can cause physical strains to a user's hands during long durations. Take a break if you feel uncomfortable or if you feel any discomfort may result in inaccurate pipetting. Do I need a filtered or unfiltered tip? A filtered tip is primarily used for sensitive assaying, especially those that require the least amount of precipitants within its array. Unless your solution is very dirty or you know your sample must be free as much contamination as possible, it's typically safe to use unfiltered tips. But do not reuse tips regardless of filtered or unfiltered. Pipetting angle. Shallow but full immersion provides the most accurate and precise extractions. As we can see in the picture, 1 centimeter extractions at a vertical angle will provide the most consistent results for our pipetting, while sinking our tip too deep or at a different angle may result in too much or too little volume being extracted, as well as putting the automatic pipette at risk of corrosion. Sources of error. Most causes for error are user-based. Bubbling solution, caused by pressing the first stop inside the liquid. Too much liquid, caused by extracting using the second stop. Too little liquid, caused by removing the tip too early during extraction or from extraction angle being skewed. Corrosion, this is caused by allowing liquid to flow inside to the pipette. In closing, medical labs and other laboratories around ASU and outside facilities utilize these tools for quality control, manufacturing, and science. It's important to remember how to use these tools of the trade and to be better scientists to prevent accidents and errors within our laboratories. This has been Dorian, and thank you for coming to my presentation.